Okay, we've got another projectile question. We are on question number 2. And here it is. We've got a particle C is projected from a point O on horizontal ground with a speed of 150 meters per second. It's going pretty damn quick. Now it's projected at an angle of 10 degrees. Not very high though, right? So it's shot out quite level. The particle moves freely under gravity after projection. And we've got to do two things. We've got to find the greatest height reached above the plane and the time at which it's reached. And then find the range of the projectile. Okay, so a few things to find out there. Jot this down, have a quick go, and we'll catch up to go through the solutions in a couple of seconds. Righto, let's get going. Now, as always, we should make a sketch to see what's actually happening. So we've got this, we've got our particle over here. It's being shot out at 150 meters per second at an angle of 10 degrees. So there it is, something like this. So what's it going to do? Well, it's going to go up and then it's going to reach some point and then start to come back downwards and then eventually smash into the ground. Cool. Now, what do we need to do? First thing is resolve. We need to resolve this into a vertical initial velocity. So we'll say u of y and a horizontal initial velocity. We'll call that u of x. So there we go. How do we resolve this? Remember, if you do not know how to resolve, check out that video down there. There's a link, follow it. It will teach you how to resolve. Now, let's crack on with this. If we're resolving to uy, so in the vertical direction, that's going to be 150 sine 10. And then ux, which is in the horizontal direction, would be 150 cos 10. There we go. Awesome. And now that we've got that, we're ready to do the question. So let's get going. The greatest height. Well, that's what we need to find, the greatest height reached above the plane, which in our diagram looks like it's over there. So what's happening at the greatest height? Well, it's going upwards, going upwards, going upwards, and then it stops, and then it comes back downwards. So at the greatest height, what we've got to remember is that the vertical velocity is equal to 0. Or we can say Vy is equal to 0 at this point. And then what we can do is, well, write in a little arrow here to show that we're trying to find the greatest height. So that's going to be the displacement in the y direction, so s of y. And now let's just set this all up into something nicely laid out. So we're looking at everything in the vertical direction here. So I'm going to put here s of y, u of y, v of y, a of y, and then t. Okay, cool. So we're looking for s of y, right? We're looking for how high it's actually got to. We've got u of y, which is the initial velocity in the vertical direction. So that's 150 sine 10. We know that when it gets to that top height over there, v of y is going to be 0 because it stops there. And now acceleration is what we've got to fill in next. Now, because so far I've taken everything going upwards to be positive, acceleration acts downwards, and so that's going to need to carry a negative sign, so negative 9.8. There we go. And time we don't need to find just yet, right? So I'm just going to put a cross here just for now. We can get rid of that later. And so what have we got? S, U, V, and A. So that looks like enough info to use V squared equals U squared plus 2AS. We need to do a little bit of rearranging because we want S. So that will be V squared minus U squared divided by 2A is going to equal S. Let's just slap in the numbers. So that's going to be 0. Take away 150 sine 10 all squared divided by 2 lots of minus 9.8. There we go. Let's punch it in the calculator. So minus 150 sine 10, close that off, squared over 2 times minus 9.8. Oh, right, that comes out as, we'll go with 3 sig figs, so we'll say 34.6 meters. There we go. So we've got that. Let's put this here. That's 34.6 meters. And now what do we need to do? We also needed to find the time when it was reached. But now, let's just get a different highlighter. And we're looking for times. I'll put that here. We've got A. We've got V as well. And we've got U. So all of this means we can actually use the easy Suvat equation, V equals U plus AT. So V equals U plus AT. So V is 0. U is, as we said, 150 sine 10. And then A is going to be minus 9.8 lots of t. So well, to solve this, all we've got to do then is 150 sine 10 divided by 9.8. That's going to give us what t is. So 150 sine 10, all divided by 9.8. And we've got time is equal to 2.366 seconds. And there we go. So we've got that. We've got the time that it reached its greatest height there, and we've got the distance as well. Next thing we need is the range of the projectile. So the range of the projectile is when it crashes into the ground, essentially how far it's gone horizontally, right? Horizontally is the main thing. So we've got to look in the horizontal direction this time. Now, what we don't quite have is any info really about this point. We don't have the time that it reaches that point. What do we have though? What do we have? Well, we know at this point it crashes into the ground. And so we know that S in the y direction, so its displacement vertically, is equal to 0. So maybe what we can do is set up some sort of suvat to find the time when it smashes into the ground. So let's do that. So we'll go with vertical again, because that's where we're looking. S of y is equal to 0. U of y is equal to 150 sine 10. V of y, we don't actually know, because we don't know the speed when it, or its velocity, sorry, when it smashes into the ground. So I'll put x over there. A in the y direction, we know is minus 9.8. And we want to find t, because we want to find when it actually hits the ground. So let's highlight what we've got. We've got S, U, A, and T. And so that there is enough to use S equals UT plus a half AT squared. Great. Let's put some numbers in. So we will have 0 equals UT, that's 150 sine 10 times T, plus a half times minus 9.8. So that's just minus 4.9 T squared. How can we solve this? We can do some factorizing, can't we? So we can take out T from there. And then we're left with 150 sine 10, take away 4.9 T. There we go. So out here we've got T is 0. That's obviously where it started from. And then over here we'll have T is equal to 150 sine 10 over 4.9. And so what does that come out as? Let's quickly type that in. 150 sine 10 divided by 4.9. And that comes out as 5.3. Well, let me put in a few decimals actually, because we're not actually finished with the calculation. So there we go. So that's the time when it smashes into the ground. And now remember, what we're looking for is the range, which is how far it's traveled horizontally. So we need to lay out some info now for the horizontal. So let's just do this up here. Let's change color as well. Let's go blue. So we'll go horizontal. Okay, so horizontally, we're looking for S in the horizontal direction, right? So how far it's gone that way. So we need that as a question mark. U in the X direction, we've done right at the start on our diagram. That's 150 cos 10. V in the X direction, we don't know, right? Don't know the speed when it hits the ground. So I'll just put X there for now. Acceleration in the X direction or horizontally is going to be 0. Okay, so gravity only acts up and down, not horizontally, so nothing there. And T, well, we know now the time when it reached there was this long decimal that we just found out, which was like 5.3157605. Okay, good. So what have we got? Well, we got S, we got U, we got A, we got T. So again, it looks like we're using S equals UT plus a half AT squared. So S equals UT plus a half AT squared. S is going to equal, well, 150 cos 10 times by T, which is that long number, 5.3157605, plus a half times, well, oh, look, acceleration is 0, which means we don't even need to write all this stuff, because a half times 0 times T squared is just 0, right? So in fact, we don't need that. Let's get rid of that. All we need is this. So let's just type it straight in the calculator. So we'll have times by 150 cos 10, and that comes out as, if we're going to 3 sig figs, that's going to be 785 meters. Okay, wonderful. So there it is, projectile question number 2 done. So remember, stick to the very basic principles, make a drawing, do some resolving, get its initial velocity in the vertical direction and the horizontal direction, and then you'll be able to solve whatever you need to from there. Done. Okay, more projectiles coming your way very, very soon, so stay tuned, and I'll catch you in another one of those real soon.